Okay, so in this video we're going to be talking about adding and subtracting radicals. So this will be a continuation of our previous video where we were talking about adding and subtracting square roots. Now the only difference in this video is that we're no longer dealing with square roots, and because of that our indexes are going to be different than 2, right? This is our index right here. So we have an index of 3, here we have an index of 4. So why don't we go ahead and just create a quick template to describe the different parts of a radical in case you missed that last video, okay? So we know that this part here, let's put 3, right? This is called our index, and our index can change, right? It could be 2, in that case it would be a square root. It could be 3, 4, 5, 6, 7, right, and so on. Our check mark here, that's called our radical. And the part underneath our radical is called our radicand. So, if you are adding and subtracting radicals, you need 2 things in common. 1, it has to have the same index. And 2, it has to have the same radicand. If they both have that in common, then you can go ahead and combine them. Alright, so again, they have to have the same index, and they have to have the same radicand. Alright, so let's take a look at number 1. So we have the cubed root of 8 plus the cubed root of 27. So doing my quick check, they do have the same index, but our radicand is not the same. Okay, so let's think about how we can go ahead and simplify this down. What is the cubed root of 8? Well, let's use prime factorization in order to find out, right? So just breaking this down, we get 4 and 2, and 2 and 2. So again, this is where my index is very important. It tells me that I need 3 of the same number in order to pull that number out from underneath the radical. So here, I have it down to its prime factors, that's what I want, and I have 3 2's. So this matches up with my index, which is 3, right? I have 3 2's. So the cubed root of 8 is simply just going to be 2, right? I just pull a 2 out. That's it. Let's look at this, the cubed root of 27. So just using prime factorization, we can do 9 and 3, and 3 and 3. So again, here I have 3 3's. Again, that matches up with my index, which is 3, so I can pull a 3 out. So the cubed root of 27 is simply just going to be 3. So it's 2 plus 3. So my final answer here is just going to be 5. Okay? Now let's take a look at number 2 because it's a little bit different. So let's go ahead and erase this. So just doing my quick check, do I have the same index? And the answer is yes, I do. It's 4. But my radicand is not the same. Notice here I have different radicands, right? So let's look at this. How can we simplify this down? So if we have 3 and then we have the 4th root of 32, let's go ahead and use prime factorization on this. We can use 8 and 4, and this will be 4 and 2, 2 and 2, and then 2 and 2. So again, look at your index, it is 4, okay? So I need 4 of the same number in order to pull that number out. So again, I have it down to its prime factors. So here, I have 4 2's. So a 2 can come out, but a 2 is going to stay behind, right? So when I do this, I get, remember the 3's on the outside, I get 3, I pull a 2 out, and you can use multiplication here, times 2, and then you have the 4th root of, remember the 2 stays behind, okay? Which is just going to be 6, and then you have the 4th root of 2. Now, if I look at what I have, right, my indexes are the same, yes, and my radicands are the same. So now we can go ahead and perform the operation. So just writing this out right here, we have minus 7, and this is to the 4th root of 2. Okay, so just doing out the operation, 6 minus 7 is negative 1, so we just get negative, and we get the 4th root of 2. So notice how my radicand does not change, alright? And this here is going to be our final answer. Okay, so that is adding and subtracting radicals.